Welcome students, myself Sachin Umre, your new lecturer of electronics. Now in the 11th standard, you have the two papers, that is a paper 1 and paper 2. From that particular paper 1 and paper 2, we are going to start the paper 2, the first topic, that is a semiconductor. In this semiconductor, first the introduction and they have given. Conductor, semiconductor and the insulator are the three types of the material. These are the three materials: the semiconductor, conductor and the insulator. Okay, you just mark out the three things, that is a semiconductor material, conductor and the insulator. This one, conductor, semiconductor and the insulator are the three types of the material. The semiconductor are those material, mark it the definition. Semiconductor are the material whose conductivity lies in between conductor and the insulator. Okay, conductivity whose lies between the conductor and the insulator. Yes, you draw the line for the examination. The most electronic devices are based on a semiconductor because at an absolute zero, what is that? At an absolute zero, that is a 0 degree temperature, the semiconductor behaves as an insulator. Okay, when as the temperature increases, the conductivity is also increases. Okay, and it is in an older day only the vacuum tubes were used. Here, the semiconductor behaves as an insulator. As the temperature increases, the conductivity increases. In the old day, only the vacuum tubes were used. But nowadays, the semiconductor device has replaced the vacuum tube device because of a number of advantages. The vacuum tube was so big. Okay, it requires a large number of space, and due to that nowadays it is being get replaced. From which component is replaced, we will see. The semiconductor devices behaves as a part where it is being used small in size and cost is less. Now these semiconductor devices have a smaller in size and the cost it is less. They don't require the heating filament and they have operated at a low voltage, and that's why it consumes a very small amount of power. Okay, this definition and the small part which is being written in the book, it is very much important as it is only the introduction. Okay, then the crystal structure of the semiconductor is explained in this topic. In this chapter they have explained the semiconductor, how it is varied. The characteristics of semiconductor diode is also described in this topic. Okay, how it is related, what is the junction, what is the P, what is the N, this whole thing is discussed in this topic in a semiconductor. Before starting, you have the atomic structure. That atomic structure, an atom consists of the nucleus surrounding the orbit electrons. The protons, neutrons are present in the nucleus. Okay, this here it is written. The proton, it is the 10th standard theory. Here you may understand that the protons have the positive charge and the neutrons are electrically neutral. Therefore, the nucleus has a positive charge and it attracts to the electrons. The number of the electrons is same as that of number of the protons. It is equal. The number of electrons is the same as that of the proton. Protons is equal to the proton. And electrons have a negative charge. It balances the nuclear attraction. The atom is electrically neutral. The atomic number is the number of protons. The atomic number is nothing but whatever the value of the proton is there, the same value is being occurred. The electrons are arranged in the orbit. These electrons has to be get arranged in a one particular orbit or a shell. Here they have, you mark it one. The electrons are arranged in the orbit or a shell. the orbit can consist of a maximum. What is the maximum? That is a 2n to the power 2. Okay, 2n raised to power 2. Here, 2n to the power 2 electrons, where n is the number of orbit. This n, it is nothing but it is a number of orbit. This n. Okay, this n, it is the number of an orbit. However, almost the orbit in an atom cannot accommodate more than the 8 electrons. It does not accommodate more than 8 electrons. It is very much important. Okay. Then the two types of the semiconductor which is discussed in this topic, that is the germanium and the silicon. In a germanium atom, the nuclear contains a 12 protons and 41 neutrons. Here you are observing it contains the 32 protons and the 41 neutrons. Means if you are able to draw that particular structure, then you are getting 2, 8, 18 and 4 electrons. Okay. 2, 8, 18 and 4. The first orbit, second orbit, third orbit, fourth orbit. Okay, according to that they have part the 2, 8, 18 and the 4. Means in the first, the 4 electrons in the first, second, third and the fourth orbit respectively. The atomic number of the silicon is 14. If it is 14, then there are 14 protons and the 14 neutrons. In a nucleus of the silicon, there are 2, 8 and the 4. Means 8 plus 2, 10, 10 plus 4, 14 electrons in the first, second and the third orbit respectively. These electrons represented in the outermost orbits are called as a valence electron. Whatever the electrons present in the outermost orbit, it is the valence electrons. Since the silicon and the germanium, there are the 4 valence electrons present in the outermost orbit of that particular silicon and the germanium. Here you are able to observe the diagram also. The structure, the atomic structure of the germanium here, and the B number, it is a silicon. Here the first orbit, second orbit, third orbit and the fourth orbit. Okay students, here the silicon, first orbit, second orbit and the third orbit. Here the outermost orbit, there are 1, 2, 3 and 4. 1, 2, 3 and 4. The outermost orbit, there are the 4 electrons. Okay, then from this particular structure, the atomic structure, you have the different energy levels. Okay, the electrons, as you know that the electrons can revolve in orbit of any radius. Wherever there is any particular formation, here it moves to any radius. But only the certain orbit size are permitted. Not all things, only certain orbit size are permitted. Any other value of a radius are forbidden. Here, any other value of the radius are forbidden. Each orbit represents the particular energy level. The first orbit, second orbit, third orbit and the fourth orbit. Means the first level, second level, third level and fourth level has been set. According to that particular setting of that particular things in a first, second, third and fourth, we are differentiating the different energy levels. Okay students. Then the electrons in a orbit close to the nucleus are tightly bound to the nucleus. Okay, if a certain amount of the external energy like a heat and the light etc. is given by the atom is said to be the state of excitation. In this particular formation, the energy level diagram, the first number, second number and third number. Okay, here the n is equal to 1, n is equal to 2, n is equal to 3. The different radius r1, r2 and r3 has been given. Okay, the edges of the nucleus has been given to you. The different numbers means the first, second, third and the fourth orbit. We have make one straight line, and that straight line indicates the different energy levels of an atoms. Okay, so for the radius number 1, you have n is equal to 1. For the radius 2, you have n is equal to 2. For radius 3, it is indicated with the n is equal to 3. The x-axis and the y-axis, it is indicated with the energy, and in the x-axis we have the different types of the nucleus. Then the energy band, When the atom combines to form a solid, the orbit of an electron is affected by the charge of many adjacent atoms. All the electrons traveling in the first orbit have a different energy level, since there are the billions of first ordered electrons. Okay. The slightly different energy level forms a band. Slightly different energy level, which will be the different, we don't know, but in this topic they have given also the different types of bands which is related. Similarly, the second and the third energy band are formed. The first band, second band, and third band, how it is related, it is given. The silicon, there are 2, 8 and the 4 electrons, the 2 first, then 8 second, and in the last, the third number orbit, it is a 4 electrons. So 2, 8 and the 4 orbit respectively. The third energy band is nothing but it is called as a valence band. Okay, what will be the valence? In this particular silicon, the 4 electrons, third number band, 2, 8 and the 4. In an germanium also, if there is a last number, the 4 electrons was present, means it was a fourth number. Okay, but in the silicon it is having the 3 number, so you have the last orbit, that is the third part, means it is called as a valence band. Wherever and anything may be. The third band are shown in the dark, indicated with the saturated band. Here you may observe here the first band, second band, valence band, and the conduction band. So it is indicated with the particular band diagram. The first band, second band, third band. This third band, it is indicate the valence band, third number orbit, and the one remaining, which is called as a conduction band. First, last orbit, it is a valence band, and the conduction band has to be shown by them. So here you have the conduction band, and whatever the gap is being present in between the conduction band and the valence band, it is indicated with the Eg. Here it is indicated by the Eg. It is the energy gap which is present in between the two, that is the conduction band and the valence band. Okay students, so from this conclusion they have compared the semiconductor, conductor and the insulator. In your examination point of view, you may read this particular combination very much well. Okay, so here they have given the comparison of a conductor, semiconductor and the insulator. First, conductor. They are a good conductor of electricity. Second number, conductivity decreases with the increase of a temperature. They have the positive temperature coefficient, that is a PTC of a resistance. Then the free electrons are a charge carrier. Example, copper, aluminum, gold and silver. Okay. The first, conductor. Second, semiconductor. Conductivity lies between the conductor and the insulator. Then the insulator, the no conductivity is occurred. This insulator is also called as a non-conductor. In a semiconductor, the conductivity increases with the increase of the temperature. They have the negative temperature coefficient, that is the NTC. As you have heard the name, NTC and the PTC. Okay, only for control of a temperature, the NTC and the PTC has been used. NTC is nothing but it is a positive negative temperature coefficient, and the PTC is nothing but it is a positive temperature coefficient. NTC is used in the semiconductor and the PTC it is used in the conductor. Then in a semiconductor, the free electrons are holes and the charge carrier. Example, that is germanium and the silicon. Up till now we have studied only the germanium and the silicon. The structure, the atomic structure, the energy band diagram, the energy level diagram. So from that particular energy band, energy level, we have studied the 3 electrons. Okay, 3 orbit. The outermost orbit is nothing but it is a valence band. And what will be the conduction is occurred? It has been indicated with a 4th number band, and that band is called as a conduction band. And whatever the gap is present in between the valence band and the conduction band, it is indicated with the Eg. Okay students, it is very much clear to you. Then the insulator, the charge carriers are absent. Example, the plastic, rubber, wood and the cotton. It is the example for the insulator, because there will be no flow of the current, So where the current is going? We don't know. So you have the plastic, rubber, wood and the cotton. The current is not able to flow from that particular body or the substance. Okay. Then we will conclude here. The next difference in a conductor, the valence band, that is a VB, overlaps the conduction. Here from the diagram you are able to understood. Here the conduction band and the valence band, it is get overlap, and that's why the energy gap is 0. Here in the conduction band and the valence band, small gap is present, and that gap is nothing but is the energy gap. It is indicated with a 1 electron volt. This much gap is present, and in the insulator, due to this particular gap, the current is going to be flow. Okay, because the gap is small. Here the insulator, the gap is large. It is 6 electron volt, and due to that one, the conduction is not occurred. The charges is not able to get touch with this particular conduction band. Okay, so the energy gap in the insulator, that is 6 electron volt. It is greater. Okay, energy gap is greater in the insulator. The energy gap is very much equal in a semiconductor, and 0 gap is present in the conductor. Okay, so in your examination point of view, this A, B and C and the comparison is very much important. Okay, we are not going to ask the total 3 comparison, but the 2 comparison, either the conductor or a semiconductor, the first comparison, or a semiconductor or the insulator, second. Then either you may ask the conductor or the insulator. So these are the 3 particular questions in a one topic, but the answer which you have to write down from this one, it will be the thoroughly answer. Okay, it should have the diagram also. This diagram is very much important, because from this particular diagram we are able to understand the how is the position for the valence band and the conduction band, what is the gap present in between the conduction and the valence band. From this it is going to be understood. Okay, these 3 diagrams will give you the conductor, semiconductor and the insulator. So it is very much important. Okay, friends, the next part we will conclude in the next time.